Perform searching for truth tables 1. Negation, implication, and equivalence. Searching objectives. By the end of this session, the student will be able to construct truth tables relating to negation, implication, and equivalent signs. Truth tables. A truth table is a mathematical table used to determine whether or not a given statement is true or false. A truth table has columns, and the column headings being the statements given. And the lowercase letters are used to label the columns, such as P, Q, R, etc. Truth table for negation. In the truth table for negation, the column headings are the statement P and its negation, that is tilde P. Now, if a statement P is Kofi is a bad boy, then its negation or denial will be Kofi is not a bad boy, and that is represented by tilde P. Now, under P, if P is true, that is, if Kofi is a bad boy, then its negation is false, meaning Kofi is not a bad boy. The same way, if Kofi is not a bad boy, then its negation, which is its denial, is true. That is, Kofi is a bad boy. And from this table, P is true, and then its negation is false. And if P is false, then its negation is true. Truth table for implication. For truth table for implication, let us consider the statements: if Asare is a Ghanaian, then he is an African. By implication, if Asare is a Ghanaian implies he is an African is true, because if Asare is a Ghanaian, then he must or he should be an African, since Ghana is in Africa. Hence, the implication is true. However, if Asare is a Ghanaian, but he is not an African, this statement is not true, meaning it is false, because all Ghanaians are Africans. So the moment Asare is a Ghanaian, he must be an African. So the statement is false. Also, if Asare is not a Ghanaian, implies he is an African. This statement may be true, because since Asare is not a Ghanaian, it means he can belong to any other African country. So therefore, this statement may be true. And the other option is that Asare is not a Ghanaian, and Asare is not an African. If Asare is not a Ghanaian, then it implies he is not an African, which may be true. So even though the two statements are false, it implies it is true. Let us look at the truth table in the next slide. Truth table for implication. In our previous slide, we saw that for the two statements P and Q, P implies Q is true, except if the first statement is true and the second statement is false. Hence, in this table, if P is true and Q is true, then P implies Q is true. That is per our example. If Asare is a Ghanaian, then he is an African. And since Ghana is in Africa, the implication is true. Next, if Asare is a Ghanaian, then Asare is not an African. This implication is false because since Asare is a Ghanaian and Ghana is in Africa, then Asare is an African. Here, the first statement is true, but the second statement is false. Hence, the implication is false. If Asare is not a Ghanaian, implies Asare is an African. This implication may be true because if Asare is not a Ghanaian, then Asare may be a citizen of any other Africa country. Hence, if he is not a Ghanaian, he may be an African. Therefore, the implication may be true. If Asare is not a Ghanaian, implies Asare is not an African. This implication may be true because if Asare is not a Ghanaian, he may not be an African. Hence, the statement is true. Truth table for equivalence. For truth table for equivalence, we consider the conditional statement if and only if. That is, if P is true and Q is true, then P implies Q is true. And the converse, Q implies P is also true. Then we say P is equivalent to Q. Now, in the equivalent truth table, if P implies Q is true and Q implies P is also true, then P is equivalent to Q. If P is true and Q is false, then P implies Q is false, since the first statement is true and the second statement is false. However, its converse, Q implies P is true. That is, Q implies P. The first statement is false, the second statement is true, which is false. P implies Q. If P is false, Q is true, then the implication is true. However, its converse, Q implies P, will be false because the first statement will be true, the second statement false. Hence, the equivalence is false. But if P is false and Q is false, then the implication P implies Q is true. And also the converse, Q implies P is also true. Hence, P is equivalent to Q, which is true. We are to show that if P implies Q and the negation of Q implies negation of P, then they are logically equivalent. Now, in the truth table below, we find the negation of P and the negation of Q. Then we find their implications. We know that if P is true, then its negation is false. If P is false, then its negation is true. If Q is true, its negation is false, and if Q is false, its negation is true. Now the implication of P and Q. If P implies Q and Q is true, P is true, then P implies Q is true. If P is true and Q is false, since the second statement is false, then its implication P implies Q is false. If P is false and Q is true, then its implication is true. If P is false, Q is false, then its implication P implies Q is true. Now the implication of their negations. If we consider the negation of Q implies negation of P, then in the table, if Q negation of Q implies negation of P and negation of Q is F, negation of P is F, then its implication is true. If the negation of Q is true, the negation of P is false, the negation of Q implies negation of P is false, since the first statement is true and the second statement is false. If the negation of Q is false, the negation of P is true, then the negation of Q implies negation of P is true. If the negation of Q is true, the negation of P is true, then negation of Q implies negation of P is true. Now in the table we saw that the P implies Q is the same as the negation of Q implies negation of P. Hence, we can conclude that logically they are equivalent.